Okay, so welcome to this very special seminar. A seminar held jointly by the College of Arts and Science, the School of Education and Human Development, the College of Engineering, the graduate schools, the Miller Schools of Medicine, and the Rosenstiel School of Marine and Atmospheric Science. So the title of the seminar is called Graduate STEM Education for the 21st Century. And it's really a remarkable report, if you have the chance to read it, from the three National Academies. The Academies of Science, the Academies of Engineering, and the Academy of Medicine. So we are fortunate to have here today a member of these prestigious academies. We have Tien, Dr. Tien, who is going to give us a report on the graduate STEM education for the 21st century. So I'd like to give you just a few lines about Jim. Jim is, of course, as you know, is a distinguished professor and Dean Emeritus of the College of Engineering at University of Miami. He is an internationally renowned researcher. He formerly served as a Yamada Corporation professor at Rensselaer Polytechnic Institute. He was also the founding chair of his department, the Department of Decision Science and Engineering Systems. And he was, at the time at RPI, a professor in the Department of Electrical, Computer and System Engineering. Jim joined the Rensselaer faculty in 1977 and twice served as his acting dean, the acting dean of engineering. In 2001, he was elected to the membership in the National Academy of Engineering, one of the highest honor bestowed to engineers. His research interests include system modeling, public policies, decision analysis, and information systems. He has served on the Institute of Electrical and Electronics Engineers Board of Directors, the famous IEEE, between 2000 and 2004, and was its vice president in charge of the Publication Services and Product Board. Jim earned his bachelor's degree in electrical engineering from Rensselaer and his PhD in system engineering and operational research from the Massachusetts Institute of Technology, MIT. So we are very honored to have Jim here to give us a seminar on this prestigious report. Jim, the floor is yours.
Oh, thank you. So let me begin by saying that this title, I think it got us members of the committee mixed up, and I don't want to mix you up, so I'm going to tell you a little bit more than just what the title seemed to say. It's all about, quote, graduate STEM education for the 21st century. However, notice something, that first of all, when we say graduate, it was just MS and PhD, not MD, not any other Ds, okay? So it was primarily just the MS and the PhD. In STEM, here's another confusion. So STEM, as we all know, means science, technology, engineering, and mathematics, correct? Okay, but we didn't have any representative from mathematics, okay? Instead, what we had was really, this is the report from the National Academies of Sciences, Engineering, M being medicine, okay? So understand that that really is beyond science and engineering, but really including medicine. Okay, so, but from our point of view, say, from the University of Miami and a lot of other universities, having medicine there is very important because they do a bulk of research through the NIH, for example. So anyway, so keep that in mind. it is a very relevant report in that sense. Okay, now who were on this committee? It's essentially M stands for medicine, science is in blue, engineering is in red. What's interesting is Alan Leshner, who's really the chair of this committee, is NIDA. NI means National Institute of Drug Abuse, and that's what he was. So once again, you can see that the medicine has a very strong component here among the members. And out of the 17 members, 11 are female, 6 are male. Okay? I say that because it was our purpose at the committee that this be a diverse group of people. And not only was it diverse, I think we are 2/3 female, 1/3 male. In terms of members, the science, there are 8, engineering, 3, and medicine, 6. Okay? So once again, you can see, and I say this makeup because really, whenever you have a committee report, you've got to look at the membership to figure out what kind of report it is. Okay, so if some of you are just in engineering and say, oh, I'm an engineer, why isn't this an engineering report? No, it isn't. In fact, it's predominantly science and medicine. Okay? Now, that doesn't mean that I disagree with what we came up with. I very much agree with it, but it was a composite report, and it wasn't just necessarily engineering. Okay. By the way, since this is a relatively small group, although I guess we're streaming, so there may be other people on the other side who can't ask questions anyway. But if you have any questions, feel free to ask a question. The sponsors, it's any kind of time we do a study at the National Academies, we also have to get sponsored in terms of somebody helping to pay the cost therein. So NSF, as we all know, Department of Education we know, Burroughs Wellcome is actually again, education, but in the medicine side of things. And Spencer is also general education. Okay, let me now talk about the task. So what we were asked to do, the agreement was that we would really need to kind of look at the career needs of graduate students. Okay, so we really took a different perspective. Usually these kinds of studies belong to faculty who are in these areas, and they will say, well, here's what we need to do. So you'll find this report somewhat different. The perspective is really saying, look, we're trying to educate graduate, MS and PhDs to have careers in STEM. Okay, so therefore we are really into what do they need, okay? Not what we, the faculty, think they need. See the perspective? It's very, very important to understand where the people were coming from in terms of doing the study. And then not only what the graduate students need, but what do employers need? Okay, because after the students graduate, they go somewhere. They go to industry, obviously. So what do employers want? And this career path that has to be not just for graduate students, in some ways we, the faculty, also have to understand the needs and so forth so that we can really give it to them and help them get there. Okay, because a lot of times the careers of our students are essentially what we, the faculty, think it should be, or we advise them. And it's really, except for the faculty that the student gets in touch with in the university, there really isn't a bigger set of people that they go to get advice. So very much, I think, if we talk about students, we have to talk about faculty in that sense of knowing how we should train them, how we should do the support of graduate students. And obviously, we're talking about graduate programs, so it's really research and training, and not so much the specific education or the material of the education. It's about also international. I mean, we realized very, very quickly that, especially in the US, it turns out that a lot of other countries send their graduate students to the US, because in the STEM area, I'm talking about STEM again. Why? Because they feel that we in the US, our colleges and universities are the best at educating people for the STEM employment. So that's very important, the international nature. And also we are really somewhat ahead of everybody else in terms of how do we go about doing graduate education. MOOCs, okay? That's the open source kinds of courses and so on. Digital learning, credentialing, and so forth. Okay? The other thing is we were trying to get the national goals for graduate STEM education. I'll be honest with you, I don't think we did very well in that. Mostly because, okay, and here's where I think we've got to really understand. This report came out recently. There's another chart. It just came out in May, at the end of May. So what we were trying to do was, we were saying, okay, so we are good at university, some, of the membership there. We were trying to get to Congress, we were trying to get to the federal agencies and so forth. We couldn't. And why couldn't we? At least in the US we couldn't. It's because, and it's still going on, unfortunately, the government is not into research, it's not into STEM, it's not into, I'm not sure what it's into, but certainly not into this. There's yet to be a director in terms of STEM kinds of activities for the federal government. I mean, it's not, we couldn't find individuals in the federal agencies who could talk on behalf of basically the administration about how they see STEM, what they think is important about STEM, if it's important. On the other hand, we've already heard things like, climate change, not to worry. It always happens, it always happens. So we just don't have any kind of sense that the government is into the STEM education at this time. Although, obviously, things has to happen at some point in time. And I think it's just taken them a lot longer getting their ducks in order for this. Okay. Whoops. So, there's supposed to be another. Okay, reshaping. This came out in 1995. I'm not sure, our report should be right there. But anyway, there's a 23-year gap between the two reports. Oh, here it is. Boy, this is fancier than I thought I did. Okay. So this is, now there's been a lot of other kinds of reports in between these two, but these were the main reports, at least officially, in regard to STEM education. Okay, so the process that we went through, we conducted reviews, of course, of reports. Like I said, it wasn't just those two reports. There are 20 reports in between if you're really interested in it. And we got public feedback. We held sessions at society meetings. We invited stakeholders to come talk to us. And I'll tell you more about who the stakeholders were. We held focus groups with students and faculty in a couple of key universities or large universities. And then we also revised, reviewed, and so forth our own report. And it's basically a 2-year effort. So what was interesting was our report was really within the last 2 years, which again, as I said, was the same 2 years that the federal government was not that much into STEM, okay, or into any kind of educational. activities. So anyway, it finally got out in May, at the end of May, and it's just really being released because even though you're done with the report, to publish it, to review it, and so forth takes a while. Okay, so as we think about the STEM education, again, remember, it's graduate, PhD, MS. It's about data programs, it's about data about programs and career paths. Okay, so what kind of career paths are we educating MS and PhD students for? It's about our feeling, we should have the breadth of technical literacy and as well about the depth. Okay, so breadth is one thing, depth is another, so it's both. Oops, now I did it. Okay. Let's see. Oh, get it on the bottom there? Yeah, right there. Oh, yeah. Okay, sorry about that. Okay, so the breadth and the depth, diversity of the learning environment, and not only diversity but inclusivity of the learning environment, develop transferable professional skills. I mean, skills that are not really necessarily STEM-like, but certainly you need communication, management, entrepreneurship. These are all related skills. Diverse career options, and as I mentioned earlier, it's also about the advisors and mentors and faculty that these graduate students come in touch with. And also provide the faculty with resources, training, and time to improve mentoring skills. I mean, even though this is obvious to us now, within the committee we had quite a bit of discussion because some people thought that they knew everything. There was no need to be educated or trained in it. And I'll be honest with you, I was one on the other side who says, I'm not sure whether we know it, okay? Because none of us, I mean, when we go through PhD, for those faculty here, when you go through PhD, are you taught how to mentor people, how to train people? I don't think so. I think we do very well with our PhD focus areas, but we need additional training and mentoring to be a good trainer and mentor. Okay? So the stakeholders, as I mentioned to you, the policymakers, obviously, colleges, university employers, faculty, administrators, and so forth. So these are all, there are a lot of stakeholders in this higher education business. It's not just, the ones and twos, but it's really a whole bunch of actors. Now, so we were really focused on, as I mentioned earlier, on student-centric graduate STEM education. Okay, now, to be honest, if you look at all the previous reports, they've all really been what I would call faculty-centric graduate STEM education, right? We, the faculty, know very well what you need, and so forth and so on. So I think the committee took a very different approach and said, look, what is it from the student's point of view? Okay, and obviously things like careers and so on are very important issues. Okay, whereas if we were doing it in faculty-centric style, we would more say, hey, my area of research is the only thing, or the best thing at least, and so on. So these are really conflicting points of view, but I think we did the right thing by going student-centric. So the student-centric is about graduate education that looks at the changing dynamics of the world, if you will, of all the demand that's out there. And previously, again, if it was faculty-centric, we would think in terms of rewarding the faculty for research output, right? Publications and funded research. Or incentives that are really much more at the institutional level and the bigger research enterprise, so to speak. But we were starting to think that we need the incentives realigned for effective student teaching, mentoring, and advising. See how we've changed that focus around? So, and that's the key difference in this report, say, versus previous reports. Okay? So as we think about the student-centric approach, then we're thinking about agencies, because a lot of, especially in the funded research side of things, the federal and state agencies are a big funder, okay? And so are the foundations and other funders. But really, it's really the federal and state. They dictate a lot of what goes on in terms of the direction of research. And then we say, well, as you incentivize research, we'll also have to incentivize the diversity, equity, and inclusion of the people involved in this research. So the STEM disciplines have to integrate the changing scientific enterprise and needs and programs and curricula. So we were taking a student perspective here. The key thing, so as we're changing this focus, we started to realize that obviously the reward system should be more about teaching and mentoring, okay? Whereas the reward system, at least for faculty, up to now is really about funded research. Is your idea good enough to get funding and so on, okay? In other words, we don't really send our faculty to go do better at teaching or mentoring. Okay, so here we're saying we better start thinking about rewarding teaching and mentoring, collecting and making available data on graduate programs and outcomes, implement practices that create equitable and inclusive environments. Again, these are quite different than where we've been. And here's a new one, by the way, for those people here who are graduate students and for those people who get NSF funding, for example, there's a new program called the Intern Program, which I will talk more about, because that really is something new, and it's something that your students who are on your research contracts can apply for, okay? And this is very interesting. This is not, your regular research funding kind of activity. Since we're looking at your career, NSF is now saying, we're going to give you money to go take time off, take 6 months off, go here, go there, see if you like that kind of career, okay? In my umpteen years of being in the higher education business, we've never heard this program before. So I think this study really has helped open the NSF to kind of funding other kinds of activities than the traditional research activity. I'll come back to this intern program here, okay? And then here we're talking about designing the doctoral research activities, projects, dissertations, to really think about STEM in terms of not just research, but education. Okay, key thing is education as well, because we're talking about not only research, but research and education. And then here's something else, that as we went along in terms of the committee, we started to realize something, and I think this is true not only of STEM, but of everywhere, where the students, they're having a lot of stresses and pressures in their educational activities, okay? And I'll be honest, I as a faculty member never thought of my students as stresses and pressures, okay? I just assume that they can handle it, that's all. But maybe they can't. And maybe what we have to do is help manage their stresses and pressures. Okay? So again, this is a switch, very much of a switch from the traditional way of looking at things, or at least looking at our students. Here's another interesting thing. Is this right? Oh, okay. I don't know what.
Good question. Okay, kind of
Sure.
philosophical question. We have focused in the past 7 years at the PhD level, to intern to the students' research, because not just in order to get published, which is obviously a goal in academia, but there was in the culture of doing research a lot of benefits, that were associated with that, that offered opportunities to many of the students that never ended up being truly academia research oriented to publish papers. And I think that, while I am obviously interested to hear what you have to say about education and teaching, and those have always been components that are important, we drove, through this program, nationally and internationally, a certain culture of advancing science and engineering through the research that we did. Are you saying really that the report and the committee that was in charge of that would say, this is after all not the most important part, we should be focusing much more on getting those people good skills to get a job, and knowing how to better teach and how better handle stress? Is that really what the committee was recommending?
Okay, no, I think because up to now, the focus has really been on maybe with research, and that's where, the funding, publications, and so on, okay? And I think what this committee tries to do now is to switch. In order to switch, you overemphasize the other side too. I agree with you that that's not what we're trying to say. But it seems that way because we're just trying to change the paradigm. Okay? Not to say that what's been there is bad, but to say, listen, we better look at the other side. That's what what we were trying to do, was to say, there's another side to it. And I'll be honest with you, what's happened with the research side, because of that great emphasis on funding and on this and on that, it really went towards, educating students for faculty positions. We didn't think about the fact that most of them will not go into faculty positions, and maybe they never wanted to go to faculty positions. Okay, so again, there's this trying to de-emphasize and try to say, let's do a more balanced look. Okay, we're not trying to say, let's just go over here and forget that. No, not at all, okay? And in fact, if you look at the committee members, most of us were academicians, okay? But we also realized that there was too much maybe, an emphasis on the academic side of research and education. So that's all we were trying to say. Good. Thanks. Yeah.
I'm his Associate Dean of Graduate Studies at Erasmus, and every semester we conduct an exit survey for all students graduating with a master's and PhD. And they're all confidential comments, but we also have just some statistics that we can compile. And one thing that does stand out is that the majority of our graduates say that they would like to have learned more about this STEM education and science outside just doing research in a lab. And many of them have broad career interests that expand beyond research. So I think this fits in very much with at least what I've seen from the exit surveys for our students' needs.
Yeah, and that's what we were starting to realize. And and I think what we're also trying to say is that we live in a different world now. Okay, and it's true. I mean, this chart I think shows a lot of look at how fast things have moved. Okay. I mean, I don't believe this, but every 18 months we double knowledge, forget it, okay? Nobody can handle that kind of, but the fact of the matter is, speeding up. It's speeding up. I mean, it really is. It's amazing what kind of speed up there's been, okay? And now as we get into AI and stuff like that, it'll be speeding up more. Okay, not to say it's good, we still haven't really learned how to define it. And I think AI is really going to really make us think twice, thrice, and so on. It's already making, big companies that do AI, okay, like Google and so on, in saying, hey, before we jump into it, and in fact, there are companies that are refusing some AI work because it is all too fast, going too fast to because, if we do AI and we have weapon system that can identify, carry out without any human partnership or intervention or analysis, maybe we are going too fast. Okay, so I think there's a lot of things going on now that the speed that we're talking about is so fast that we're not sure whether it's controlling us or we're controlling it. I mean, we're at that stage. It's really very tenuous, I think. So I think part of this is that the educational process is also now saying, let's look at exactly what we're doing or where we think the educational process should go, even in just the STEM area. So this doubling of the curve is really, it's evolving, okay? New and emerging fields are evolving. I mean, look at how fast. Cloud computing, big data, nanoscience, AI, gene editing, and so on. This is all within at the beginning of this century. Okay, this is not last century, we're still trying to catch up. This is all coming at us at the beginning of this century. Okay? And then here's the other key thing that I was talking to, where's Mohammed? Oh, right there. So he and I have a big discussion about this, not argument, discussion. Okay? This is something that we've really never learned to teach our students. Why? Because we haven't been taught. We don't know how to do this. Okay? Today, it's all about group activities, joint research. Companies are never paying anybody and say, oh, you just do that, and you do that, and you do that. Okay? They say, hey, let's all get together. We got to do this. We got to march down here. And so it's all group activities. Do you realize something that we in academia, and I'm as much at fault as every faculty here, have we ever done a joint PhD or even a joint master's thesis? Have we? No. It's much easier for me to kind of supervise an individual because I can then give you a grade, good, bad, A, B, C, whatever. Okay? But we have not learned how to educate in a group sense. Okay? Joint PhD, joint masters, and so on. I haven't. Okay? I'll be honest about it. And nor has anybody else. And we tend not to want to do that, especially faculty. Faculty, we don't know how to do it. Why? Because we were never educating it. Okay? And maybe we ought to start thinking about this. Because I think 2 minds are better than 1. 3 are even better, and so on. Okay? And every single advance from now onwards is very much a group activity. The days of having single, breakthroughs, they're still going to be there. I'm not saying they won't. But the big breakthroughs are going to be group activities. Okay? And so it should be. So anyway, so here's a solitary research activity is got to make way for group activities. Well, I think all of these are related to what I just said, which is really looking at it from a whole, total different perspective, okay, of going from an individual to a group. Okay, so this is the STEM program. We've got, Helena, we've got those single sheets, and you can come and pick them up and so forth. But very, very briefly, this is what's called the new Nsf Intern Program. What it is, it says, okay, if you, the faculty, have a NSF grant, then any of the students in that grant can apply for this. It's essentially $55,000 per student per 6 months. So they can get 2 of those assignments, okay? They can work for a company, a small company. They can work for an agency or whatever. Though, for $55,000 for 6 months, you can, live pretty well and get paid pretty well, okay? But it essentially is helping you to get to that career point in your life, okay? It is no longer me telling you, the faculty telling you, oh, you do this, you do that. Okay, so here's an opportunity for you to take time off, okay, and certainly taking 6 months or a year off to find yourself, that's pretty good, okay? So again, our emphasis is, hey, let the students kind of initiate these things, okay, because typically it's the faculty who tells you what to do. If you don't want to do it, good, I won't fund you, so I don't know how else you're going to do it, okay? So this is a very big switch that NSF, and this just came about just last month, really, okay? And so if you have any student on your NSF, it's got to be an NSF grant, you can help them by telling them, hey, whenever you're ready, let's apply for one of this, and you can help yourself to figure out, maybe if Google is not necessarily hiring, it's okay. You have your own money. You go to Google and you just need, and I'm sure they'll say, oh yeah, sure, come on, you're a freebie to us, okay? Not really, NSF is paying for it. Oops, what did I just do? Switch. Okay, so there's a lot of, it's a 2-page, one, it's a double-sided sheet there that you can pick up, really. And if you're a faculty member or anybody, pick one of those things up because it will help you in your future research activities to get your students involved in defining their own career after they get done with their graduate studies. Remember, this is MS, PhD effort after that. Okay, so this is an interesting chart that I totally forgot about. I remember telling my students, the students I thought would be doing good to go to grad school and blah, 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 blah. And one of the things I used this chart for many times, and JP, you probably did too, and telling them, look, if you go from bachelor's to master's to PhD, you'll earn more. Over your lifetime, you'll earn more, okay, and so forth. Because not only will you be doing interesting things, but you'll earn more, okay? And this is what this chart says. And essentially, this here, the maximum occurs at around age 50, okay? That age 50, you would have already been on top. After that, sorry, you're last generation, so you start decreasing in terms of earning. But anyway, the emphasis here again is that the higher degree, the more you're going to earn. Okay, and obviously, if you earn more every year, cumulatively speaking, you will earn more in your lifetime. Okay, in your career. Okay, that's it. Love to have discussion or questions. Yes. Yes.
May I you can take questions.
You mentioned... Fala português.
So, as usual, very, very informative lecture. 2 questions. One, you mentioned that you have the need, one of the tasks was towards the need of employers. And in another chart, you mentioned the participation of stakeholders. How was the processing of getting information from the employers and in different areas, as you mentioned, non-government, industry, agencies? How was the participation of the needs of the market in this report?
Yeah, that's a good question, and I think we did a relatively good obtaining input from students, from faculty, but not from industry or government. Okay, government especially. We had nobody to go to in government, okay, because they were all trying to find themselves what they were supposed to do for themselves. Industry, we got quite a few industry, but the problem with industry is that there's thousands of them. Each one you speak to has his or her own perspective, given the industry. Okay, like we had, for example, a lot of chemists, okay, and they were into, okay, we're just wanting to do chemistry, but we're not really into all these other things. So it's hard to get the conversation going. And that's typically true of this kind of study. Okay, you try to cover the world, but you can't. And then you're left with the luck of getting the right people.
May I, one more?
Sure.
We have some more questions. I can actually.
Okay.
Elena, please.
Yes, and I just wanted to add, in terms of the Nsf Intern Program, that we currently have a student that's supported in engineering on the intern program. He works with Dr. James Engelhardt. James Engelhardt does net zero water recycling, and the company that the student's working for is installing a net zero water system for commercial use. And so it was interesting how he was able to combine both the research side and the application of the research with the NSF interns, so the student is actually implementing what he, in real life, what he learned in the experimental aspects here on campus.
Yeah, I think that's great. I mean, he lucked out in that way because you don't need to have your application of research as being part of it. He could have just taken off and say, hey, I want to go see this other company. I don't know what they do, but I want to. So it's a lot freer, I guess, is what I'm trying to say. Yes, sir.
Is there any information in this report about the impact of this change in the approach on accreditation of various degree programs, especially in STEM and engineering, as a result of the shift from that student perspective or more of a interdisciplinary approach versus very focused PhD-focused education?
That's a good question, and since the report just came out and we're making recommendation, nothing's really happened. I think NSF or whoever should really have a follow-on assessment report. You know, that might answer some of this.
Within our department, kind of a debate on this topic because there's a number of new courses that we are rolling out for the construction management program, and we debated who should be permitted, should the PhD students be permitted to take those courses? And a lot of faculty felt strongly that they should not be.
Right.
And so this kind of,
yeah, that's.
there was innovation, there was entrepreneurship indicated, management indicated in there, and so from that point of view.
Yeah, I think, again, my personal feeling is obviously these are important things. Unfortunately, you can't keep loading everything on, okay? It's still just a, I don't know, 5-year PhD maybe, but it's growing longer if we keep loading too much.
Yeah, should we consider splitting the doctorate and having a PhD that remains focused on generation of new knowledge, using whatever disciplinary techniques we have at hand, and consider another doctorate that is more cross-disciplinary, more of a kind, because when you start talking about industry and business, you're talking more applications-driven, not in the sense that people think about as basic research or whatever. And I'm just wondering if, in fact, we're asking the PhD to do things that it's not designed to do.
I think you're right, but on the other hand, the biggest problem is if you decide that at the point of entry into that PhD or this PhD, it's very hard to do because a lot of us over time changed. We switch over before we even know it that we've switched. Okay, so that would be my only caution there, is that we don't want to close doors, at too early a point. I think, essentially the student and the faculty member right now are the determining activity. I mean, like, for example, I usually try to get my PhDs go get some industrial experience before getting started with PhD. So that's my personal view, because it was very helpful to me to understand what you're getting your PhD in. So I agree with you in some ways, but then that's just one way of looking at it.
Tim, I have a question, if I may use my prerogative here. You showed a graph where knowledge is growing exponentially.
Yeah, the last one, right? Yeah.
And we like to think at universities that a PhD, the doctorate, is the first step in knowledge creation. Actually, the distinction between an MS and a doctorate is really knowledge creation, original knowledge creation.
Right.
A doctorate is supposed to bring to life new ideas.
Right.
Now, obviously, the number of PhDs and doctorates does not grow exponentially. So I can see here a gap, which is growing over time. The academies kind of are reflecting on this gap, where now the knowledge is no longer created at universities, it's created outside universities, and all kind of knowledge, because that graph doesn't tell you if the value of the knowledge. It's telling you that the knowledge is increasing. Is this a threat to academia that we are facing? Is this the need for us to educate our researchers, to educate other researchers, so we can continue the legacy of the past? I can feel like you are on something extremely important.
Right. Yeah, no.
I sense that your committee did some radical thinking on what we do here, or what we take granted on a daily basis.
Yeah.
I think we are at the threat of academia losing what so far we have guarded as the supremacy of knowledge creation. I think this is what it is. If we don't educate the researchers, then we may lose what so far we have enjoyed. So I just wanted to, that point really touched me profoundly. Thank you, Jim. It's really
I think you're totally right. I think we in academia, okay, and I count myself because I spent too much time here, but it's different. The world is changing, and it's changing so fast that you're right. We might be at the tail end of it and not ever catching up. Meanwhile, the world goes by us.
Of course, it's for STEM. I mean, I don't speak for disciplines, other disciplines, like the art or music or so on.
But they're starting to meld together. This whole AI stuff, like, for example, AI is going to make artists, okay, do things that they never thought they would do. I mean, music, any kind of art. I mean, so it's coming together faster than we would like to think of it. And we can't stop everything and say, oh, let me do the research, or let me do the impact analysis before you do that.
So,
no, you're right.
So I think we need to educate all doctoral students to train others. So this passing of the torch is really critical, okay? So we can be more effective at knowledge creation. And I love your ideas of joint PhD. I mean, all of us went through that. If you have your doctorate, it was the most isolating experience in your life. It's you against the others. Does it make sense? Really?
Well, doesn't the joint PhD almost fit the gap that you just described?
Yeah, so it's alarming. But I'm thinking also about how is it efficient for us, and Jim articulated well, to create new knowledge, by dividing us into silos. I mean, the silos effect starts right from here. We have been harboring silos in our lives. We are not effective at generating knowledge when you're alone. And a PhD is the most, it's loneliness by definition.
I think, that we should go through that, but that's not where we should end.
Yes.
The problem is we went through that and we ended there.
Yes.
Okay? I think it's time to come say, yes, there's a lot of goodness to trying to figure out yourself first, but then, hey, the world is made up of joint activities, not singular activities.
And I think we should not extend it into tenure. In tenure, we actually demand.
Right. What did you do?
I don't know. Well, I think we should reevaluate the tenures to make sure those who are working in teams are not punished by and being taxed of not having original ideas. I think there are some profound radical values that you brought to the surface, Jim. Thank you. That is really thought-provoking.
It's my pleasure.
So if we don't have any more questions,
He had one more
Yes,
question that he didn't.
It was exactly about educating researchers,
Yes.
One of the topics is solitary research activities are giving away to team-based PhD, joint PhD, right? My question is, and based on my experience here with some students, I separate in groups for group discussion and group preparations. My purpose was that they would get together in person to connect, to explore human connections. And what they did was using WhatsApp, and they did the group presentation together through the WhatsApp. Question, how to balance a joint PhD dissertation, how to educate the researchers in the sense of working in group, because this is the real world outside the academia, considering that they are, today we have this massive use of social media.
Right.
How to bring them together to develop also human connection.
Well, I think we have to experiment. That's what we have to do. I mean, first we ought to allow for joint PhDs. And then we have to figure out how am I going to evaluate that. Okay, because we've never understood how to evaluate jointness. Never, right? I mean, in our research, forget that, but even in projects, okay? Student projects, we don't know how to do that. We really don't. And I think we as educators, we should really start to think that way and say, okay, here's how we did it. It worked out okay here, but not there. Okay, and that's what we're missing a lot. And STEM is a critical area to be able to do jointness because that's what it's all about.
Maybe T should stand for team.
Team, there we go, STEM.
I'd like to thank Dr. Hural, who organized the seminar. Thank you, Dr. Hural. And I'd like also to thank all the speakers. The participant and the speaker. So why don't we just give him a round of applause?
Thank you.